is never eclipsed by Earth. At L1, Aditya-L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य-L1 उपग्रह को भी ऐसे ही लैग्रेंज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फ़ायदे होते हैं, जैसे हम यहाँ आदित्य-L1 के बारे में बात कर रहे हैं तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृत्ति नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya-L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere, and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle, and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph (VELC), which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit, and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE, and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition, and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नित भार के बारे में जानते हुए इसमें सुदूर संवेदन नित भार हैं और यथास्थिति प्रेक्षण नित भार लगे हुए हैं। सुदूर संवेदन नित भार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HE-L1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति निदभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य L1 के निदभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VELC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही UR राव सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India's made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hat.
Range operation
In
director.
fact, these celestial
As per
bodies
telemetry
are
station
very
deployment
important and
for
are considered as
loss of
sacred
signal
bodies
for
in
biaxial
multiple
shutdown.
global religions.
Vehicle is now
The
in
sun
non
is the
visibility
central
phase.
body of our solar
The
system.
non-visibility period
the world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya-L1 space mission. So today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya-L1 mission, Dr. Durgesh Tripathi, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya-L1 launch. To start with the Principal Scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya-L1 mission so important, and what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And Sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India, and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wave bands which are very important for the Earth ionospheric connections, like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the Sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology, as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we move on to Dr. Anil Bharadwaj. So the Sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya-L1 helps us through the mission?
Thank you, and good morning, viewers. First of all, let me tell you that Aditya-L1 is a multi-wavelength, multi-instrument, and multi-directional mission. Multi-wavelength because it works in X-rays, UV, and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the Sun direction but also around it. Now, when the Sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the Earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the Earth. What we are looking for from the Aditya-L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the Earth. We have instruments which look at not only in the Sun direction, but also in other directions, for example, perpendicular to ecliptic or in the Earth directions. The impact is that we need to see when the Sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun and the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7 through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we planning to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. Thank you.
That was very interesting, Doctor. Thank you very much. And now we'll move on to Durgesh Tripathi, Dr. Durgesh Tripathi. You are the PI of the for the payload suit. How is that different from other telescopes like Hubble or James Webb? And what are you going to investigate using this?
Yeah, so good afternoon. My voice is going to mumble because I'm still in the awe of the launch and one of the payload is gone there. So essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star formation, and other objects you see in the universe. Whereas when we talk about Aditya-L1, it is going to look at one particular object, which is our sun. And it's also kept on the other side of the sun-Earth line at the L1 point, whereas the James Webb Telescope went on the other side of the Earth, which is at the L2 point. Now, the scientific difference, of course, they also observe in ultraviolet, but Aditya, as Professor Anil Bharadwaj and also Professor Annapurni Subramaniam alluded to, these are multi-wavelength satellite, and they will be observing all across the electromagnetic spectrum. In particular, SUIT is going to be looking at the ultraviolet radiation in 2000 to 4000 angstrom, if that matters to you, emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and how actually this radiation is coming and getting absorbed in the Earth's atmosphere, and what kind of effect it can have in the chemistry of ozone and oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have. Thank you.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds, and how does it impact?
Thank you. Thank you for giving opportunity to come into this role. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that is the sun. Just I want to tell to the viewers that actually the sun, which is our hero, basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also, this sun is plasma. Now, when we are talking about the heliosphere, actually, with this, all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we were lacking actually a comprehensive approach, because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all these radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is the opportunity we got actually. We are trying to understand actually all the three things: radiation, particles, and field. Already they mentioned about the radiation. Now, Dr. Vivin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of Vikram Sarabhai Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha particles roughly around 4 to 5%, then equal number of electrons also. So our PAPA is a comprehensive package measuring both ions and the electrons. Now these electrons, like already our colleagues, they mentioned actually the major transition events like coronal mass ejection. That's a huge mass which is coming out of sun. Basically it's a plasma. Basically when we are talking about solar and basically nothing but it's the extension of the corona only. That's the atmosphere. Now these particles actually, they only actually modulate the energy and momentum of the planetary atmospheres. See, when then sun is quiet, like it is not aggressive, sun is what we are getting the ambient solar wind. So if you look into that thing actually, that one actually gives what we call about the interactions, what we call the normal routine phenomenon which is happening on there. But when there is sun is angry, actually it gives like in a CME, CAR, or these sort of events are happening, that is really going to affect our planets. That's what we call the space weather. Now our intention is to understand, first of all, actually what these effects, basically the solar wind, in the ambient condition as well as during this transition events, how this solar wind behaves, and also how this coronal mass ejections which is passing through different planets, how actually, what are the different things, like what we call about the microphysics, macrophysics, and the mesophysics of that things, that we want to understand. So one thing is actually it's a physics subjective to understand, because we are getting an ideal point, Lagrangian point, which is in the sun-earth plane, and we will be seeing the events exactly there. Second thing is actually, we can definitely monitor the parameters. Like, particularly PAPA will measure electrons and ions, we will be getting energy, direction, and angular information, mass information. So if we know these things related to electrons, electrons we don't want the mass, but for the ions we are getting the mass information. Okay. Coupling all this information, actually what we can do is we can derive the plasma moments. That will be definitely going to the modeling part, actually dynamics part, and that will definitely going to tell about the effect of the space weather effects.
Yes.
So in due course, actually, with the L1, in addition to other L5 missions, we will be able to tell. This is the importance of the plasma missions.
Yes.
That actually, as you mentioned, actually earlier with the lunar mission we achieved, we tried to understand that thing. Really, it changed, this plasma studies changed the perspective of the moon. Now, Aditya will give more detail about that.
Yes.
Thank you.
Thank you, sir. Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. So, you manage the beautiful solar observatory at Nainital. How do you think the studies of heliophysics will supplement Aditya-L1? Can you tell us something about the history of solar observatories in India?
That's right. India has a long tradition of looking at the sun from the ground. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. And also we have beautiful, solar observatory at Udaipur, in the lakeside, and at Nainital. We are looking at the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. So this was very, very important that we could go to the space. And this is a fantastic opportunity. Originally, more than 10 years back, we were only looking at a small satellite program. And then Professor U.R. Rao suddenly came up with this idea, why are we taking baby steps? We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian mission. The entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian observatory class mission. And as you heard from my colleagues, that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage from the space. And in addition, the ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And since you asked about the question about the, how Aditya in the overall heliophysics research within the international scenario, we only have 3 spacecraft around Lagrangian 1 point primarily from NASA and ESA. So I think again, this is a fantastic achievement from India. If you could reach L1 with the full observatory class mission, it will really open a new window altogether. So I think this is a great opportunity, and we are all looking forward. And as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have a very nice ground-based telescope also to complement the capabilities of Aditya-L1.
Thank you very much, sir. Indeed, it's a very great opportunity. And now we move on to Dr. Vipin K. Yadav. So you're in charge of the magnetometer. What is the contribution of magnetometer to Aditya program?
You see, the magnetic field measurements are very crucial in space, and especially at L1 point. What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from Sun and towards the Earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event, such as the coronal mass ejection or say a solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements, and apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres, and how does Aditya-L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to the 27 arcs to 10 to the 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are 2 unique instruments built by URAV Satellite Center that is going to cover the solar flares from 1 kV to extremely high energy, about 200 kV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these 2 instruments, along with the other 2 instruments, VLC and SUIT, we are going to address this $1 million questions, as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya-L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya-L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the ASPECTS payload, which stands for Aditya Solar Wind Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming and whether the plasma is getting accelerated in between when it comes from sun towards earth, and therefore there is a multi-directional information which is available from the aspects payload because it consists of two sensors, Swiss and STEP, essentially giving you in two different energy bands, and therefore we'll be able to quantify the CME, CIRs, and all the processes which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankar Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrostat and Aditya-L1?
Yeah, so now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it, because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle, because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya-L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards sun. So it is very important that the younger generation, comes into the research and also utilizes the data. These scientific missions are for the community, and it has to be the community driven. So some of our scientists, who have been engaged with this mission for decades, we understand what is expected to be, this data. But the younger generation, they need to be trained. And so for that reason, we also have a Aditya support cell at Nainital, and we are going around in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to other, people who are particularly in the universities or IITs, because they have so far not been directly involved with the Aditya mission. So I think we are really, really going out, and we expect that the youngsters, the next generation will come and utilize this data, because the data is for the community. So unless, we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan-3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan-3 mission, that is the Aditya-L1 mission and Chandrayaan-3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you very much.
Thank you everybody for participating in this discussion, and now we move on to the control room.
Thank you, Srinidhi, and I thank all the panelists for enlightening us about the high-tech science that Aditya-L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं, यह पूर्वानुमानित पथ दिखाया जा रहा है। यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV-C57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था। और फिर
टर्मिनल acquires telemetry signal.
जी हाँ, इसकी पुष्टि हो गई है। शिपबोर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV-C57 Aditya-L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, SHAR, Sriharikota. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Four-stage engine started for band 2.
यहाँ अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
Very happy piece of news here.
Normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV XL रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं, हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage currently burning for the second time.
Fourth stage performance normal.
Intended trajectory closely matching the prediction. Presently, the shipborne terminal is acquiring the signal. Few seconds later, there will be another no visibility phase before Koru starts to acquire signal.
जी, अभी द्वितीय बर्न चालू है PS4 स्टेज का। अभी कुछ 200 और सेकेंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा से एक समीप का सितारा रहा है हमारे लिए। असल में यह गर्म आग का गोला है जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा प्राप्त करता है और इस ऊर्जा से इस सौर मंडल को एक परिवार के भांति समेटे हुए है। पृथ्वी से सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य ही हमारी ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. The next telemetry station is Kuru. The telemetry signal break will be approximately 205 seconds. During this non-visibility period, ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन कुरु स्थित फ्रेंच गयाना स्थित कुरु स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya-L1 will not travel directly to the L1 point. Transfer maneuvers will be performed to position the spacecraft in a halo orbit. Aditya-L1 will first be made to perform maneuvers in Earth orbit. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, its systems, payloads and the orbital parameters. Burn to exit Earth's sphere of influence will be initiated. After exit from SOI, the cruise phase will start and subsequently the spacecraft will be injected into a large halo orbit along L1. The total travel time from launch to L1 will take about 4 months for Aditya-L1.
इस दौरान आइए आपको अवगत करा दें आदित्य-L1 के मुख्य उद्देश्य से। आदित्य-L1 मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में महत्वपूर्ण जानकारियां उपलब्ध कराना और इन गतिविधियों का अंतरिक्ष मौसम के असर का अध्ययन करना। इस कार्य के लिए इसमें 7 निर्भार लगे हुए हैं जिनकी मदद से आदित्य-L1 फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के बाहरी परत के विभिन्न वेवलेंथ में प्रेक्षण कर सकेगा। विशेष वैज्ञानिक उद्देश्य इस प्रकार हैं: सूर्य के ऊपरी परत जिसे हम कोरोना के नाम से जानते हैं, इसकी गतिकी का अध्ययन करना, क्रोमोस्फीयर और कोरोनल तापमान, आंशिक रूप से आयनिक प्लाज्मा की भौतिकी, कोरोनल मास इजेक्शन की शुरुआत और फ्लेयर्स का अध्ययन, सूर्य के कण की गतिशीलता के अध्ययन के लिए आंकड़े प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के प्रेक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की अब चतुर्थ चरण को बंद कर दिया गया है। अब उसका थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है और इसकी भी पुष्टि हो चुकी है कि आदित्य-L1 के अंतःक्षेपण की स्थितियां प्राप्त की जा चुकी हैं।
We are now eagerly awaiting the injection of the satellite as we have the confirmation from the Range Operations Director that the thrust cutoff for 4th stage of PSLV has been achieved. We are 1 hour into the flight.
कुछ ही क्षणों में क्रूज स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी।
Highly anticipated event next is the separation event of Aditya-L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। यान से अंतरिक्ष यान आदित्य-L1 का सफलतापूर्ण अंतःक्षेपण अभी बाकी है।
For Aditya-L1, ISRO has developed advanced flight dynamics software to obtain past trajectory data from tracking, apply mathematical computation to calculate present and future location of the spacecraft in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance.
अब तक कुल 22 सौर मिशनों को नासा, ईसा, जर्मन
Aditya-L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है, इसकी पुष्टि कर दी गई है। आदित्य L1
Aditya-L1 mission accomplished. Handing over to mission director.
And we have a confirmation of Aditya-L1 separation. The mission has been accomplished.
PSLV-C57 has injected Aditya-L1 satellite into the desired intermediate orbit. PSLV-C57 Aditya-L1 mission is accomplished.
आदित्य L1 को पूर्ण परिशुद्धता से इसके निर्धारित कक्षा में स्थापित कर दिया गया है। इसके बाद वह अपने आगे की सफर जारी रखेगा L1 पॉइंट के लिए।
Do join us for the address by Chairman ISRO Secretary Department of Space Shri S. Somnath.
सभी दर्शकों को शुभकामनाएं और बधाइयां इस मिशन की सफलता के लिए। अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए।
Congratulations. The Aditya-L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2 burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission of Aditya-L1 to put it in the right orbit. Now, from now, the Aditya-L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, a very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh. So I request him to speak a few words.
Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya-L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Nijri, NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of her 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
May I request the Project Director of Aditya-L1, Nigar Shaji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya-L1, and I'm extremely happy that Aditya-L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya-L1 solar panels are deployed, and the spacecraft will be normal. And Aditya-L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans-L1 injection, and finally insertion into the halo orbit in the Sun-Earth Lagrangian point L1. Once the Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the center directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further great science output from the Aditya-L1 mission. Thank you all.
Sri Biju, the Mission Director and the Project Director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya-L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed very it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal, as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya-L1 mission, just following the Chandrayaan-3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you. Contribution from across the center, this could be done. So let me start with the Director VSSC.
Good afternoon, India. So this is the 59th mission of PSLV, and 1993 was the first mission. So this is the 30th year of PSLV. So it's PSLV is on the threshold of Shashti Purti. With the next launch, it will be making 60th launch. I wish all the very best to the satellite team, all payload specialists for the operation of the payloads and satellite in coming days. And I'm take this opportunity.
The launch event of India's prestigious LVM-3 M4 Chandrayaan-3, the mission of ISRO to the moon. I am Madhuri giving the commentary in English. With me is my co-commentator Shri Vikas Swarnkar giving the commentary in Hindi. We are joining you from the Mission Control Center at Satish Dhawan Space Center, SHAR, Sriharikota, the spaceport of India. The launch of LVM-3 M4 Chandrayaan-3 is scheduled to take place today, the 14th of July 2023 at 14:35 hours Indian Standard Time from the second launch pad. The mission intends to place Chandrayaan-3 weighing 3,900 kilograms into an elliptical parking orbit having a perigee of 170 kilometers, an apogee of 36,500 kilometers, and an inclination of 21.3 degrees. Eventually, the destination of Chandrayaan-3 is the moon, located 384,000 kilometers away, which will be achieved through a series of orbit raising and course correction maneuvers over the next few weeks.
नमस्कार। भारतीय अंतरिक्ष अभियान और इसरो के गौरवपूर्ण इतिहास में एक और अध्याय जुड़ने जा रहा है, जिसके साक्षी हम सब होंगे। आज 14 जुलाई 2023 को इसरो के सतीश धवन अंतरिक्ष केंद्र के श्रीहरिकोटा के द्वितीय प्रमोचन मंच से भारतीय मानक समय के अनुसार दोपहर 2:35 पर LVM-3 M4 चंद्रयान-3 मिशन का प्रमोचन किया जाएगा। यह पूरे भारतवर्ष के लिए एक उत्साह और गौरवपूर्ण भरा समय है। हम मिशन नियंत्रण कक्ष से मैं विकास स्वर्णकार, अपने साथी कमेंटेटर मिस माधुरी पी के साथ आप सभी दर्शकों का हार्दिक स्वागत करते हैं। हम आपको मिशन से जुड़ी सारी जानकारियां तथा आंखों देखा हाल सुनाते रहेंगे, तो बने रहिए हमारे साथ और साक्षी बनिए इस ऐतिहासिक मिशन के लिए।
TC SHAR 1 and 2।
इस मिशन को कुल 4 मुख्य भागों में बांटा गया है। पहला, चंद्रयान 3 अंतरिक्ष यान को LVM-3 द्वारा 170 बाई 36,500 किलोमीटर की इलिप्टिकल पार्किंग ऑर्बिट में 21 डिग्री के झुकाव के साथ अंतक्षेपित किया जाना। दूसरा, पृथ्वी की कक्षा को छोड़ चंद्रमा की कक्षा में जाना। तीसरा, चंद्रमा की सतह पर लैंडर का सुरक्षित लैंड करना। और अंत में रोवर का चंद्रमा की सतह पर विचरण करके तात्विक तथा रासायनिक विश्लेषण कर वैज्ञानिक आंकड़े जुटाना।
On your TV screen, Honorable Minister of State for Science and Technology and Prime Minister's Office, Dr. Jitendra Singh.
जी हाँ, आज के मुख्य अतिथि के रूप में यहाँ उपस्थित हैं विज्ञान और प्रौद्योगिकी राज्य मंत्री माननीय डॉक्टर जितेंद्र सिंह।
We are about 31 minutes from the scheduled launch time. You're watching this live from the Mission Control Center. Apart from Doordarshan, you can also watch the launch event on ISRO website, YouTube, Facebook and Twitter.
आपको ज्ञात हो, चंद्रयान 1 22 अक्टूबर 2008 को PSLV-C11 द्वारा प्रक्षेपित किया गया था और 8 नवंबर 2008 को वह चंद्रमा की कक्षा में जाने में सफल रहा था और अपने मिशन का उद्देश्य पूरा किया, जिसमें चंद्रमा पर पानी की खोज भी शामिल है। फिर 29 अगस्त 2009 में चंद्रयान 1 से हमारा संपर्क किसी कारणवश टूट गया, लेकिन इसमें मील के पत्थर ने चंद्रयान 2 का मार्ग प्रशस्त किया था। चंद्रयान 2, जिसमें ऑर्बिटर के साथ चंद्रमा की सतह पर उतरने के लिए लैंडर और आसपास के क्षेत्र का विश्लेषण करने के लिए रोवर की अभिकल्पना की गई थी। चंद्रयान 2 को जुलाई 2019 को भेजा गया था। इसमें ऑर्बिटर ने भली भांति अपना मिशन पूरा किया, लेकिन लैंडर मॉड्यूल चंद्रमा की सतह पर सुरक्षित उतरने में असफल रहा था। इसके पश्चात गहन अध्ययन और उन्नत तकनीक से परिपूर्ण सभी परीक्षणों और सिमुलेशन के पश्चात तैयार है सुदृढ़ चंद्रयान 3। आपको संक्षिप्त में LVM-3 M4 प्रमोचक यान की जानकारी देते हैं। LVM-3 प्रमोचक यान अन्य सभी यानों की तुलना में सबसे अधिक विकसित तथा उन्नत अभिकल्पित किया गया है। इसकी ऊंचाई 43.5 मीटर तथा व्यास 4 मीटर का होता है। इसका कुल उत्थापन भार 640 टन का होता है। यह 3 चरणीय यान है, जिसकी क्षमता 4 टन के नितभार को भूतुल्यकाली अंतरण कक्षा में यानी 180 बाई 36,000 किलोमीटर में ले जाने की क्षमता है तथा 8 टन के नितभार को निम्न कक्षा में स्थापित करने की क्षमता है। इस यान में प्रथम चरण में 2 S200 स्टेप-ऑन बूस्टर्स लगे होते हैं, जो कि ठोस नोदक पर आधारित चरण हैं, जिन्हें सतीश धवन अंतरिक्ष केंद्र में उन्नत और परिपक्व उत्पादन प्रणाली द्वारा निर्मित किया जाता है। दोनों S200 के मध्य में L110 चरण है, जो कि तरल नोदक पर आधारित चरण है और इसके ऊपर की ओर 28 टन के क्रायोजेनिक ईंधन वाले C20 इंजन का प्रयोग करते हुए C25 चरण है, जो कि भारत का सबसे बड़ा क्रायोजेनिक इंजन है। इसे इसरो के लिक्विड प्रोपल्शन सिस्टम सेंटर IPRC द्वारा विकसित किया गया है।
Yeah. Should I sum up a little humble? Big hustle on this one. MC. Yeah. Know what time it is?
Spend more time in my hustle than I did with you. I used to spend more money with my guys than I did for you. If I told a lie, I did it for you, and you my overplug. If another try, electrocute. Spend more time in my hustle than I did with you. Used to spend more money with my guys than I did for you. If I told a lie, I did it for you, and you my overplug. If another try, electrocute. They said I'm humble, ay, so she wanna have my keys and bring some trouble. Wait. How many guys here been with a couple of dozens? A Cameroonian bundle, she put the guys on shuffle. Let work go down, intoxicate my brain. Yeah, Whippy go use a cane. I be your Elon, build a spaceship, masking you away. Didn't have a single goddamn choice. If the one that could be the voice. 1 a.m. until the morning, we gon' make the noise. All that shit gon' go away. Don't you come another day. Now I need you back. Moments with you were the only occasions I wasn't sad. I love you back. Choosing between you and you sure as hell gon' make me mad. Yeah, but man, the boy done turn a rapper. This a fan. More time in my hustle than I did with you. I used to spend more money with my guys than I did for you. If I told a lie, I did it for you. And you my overplug. If another try, electrocute. Spend more time in my hustle than I did with you. Used to spend more money with my guys than I did for you. If I told a lie, I did it for you. And you my overplug. If another try, electrocute.
Yeah, hold up, baby. You acting shady. Don't like how you treat me lately. You don't appreciate me. Talking to me crazy. Work hard, but you say I'm lazy. I'm starting to think, yeah, this love is fugazi. You got me thinking a lot when I'm on the plane, yeah. Do you love me the same, yeah? Am I all in your brain, yeah? I'm in the mix, yeah. I'm trying to get rich, yeah. I'm grinding. How was you pissed? Look at the time, you don't give a shit, yeah. I gotta make a decision, better my vision, aim in position. I don't like how I'm living. Shit, it feel like you just hate it when I'm coolin' with the guys. I know you just want me doing nothing at the house. Gotta
Spend more time in my hustle than I did with you. I used to spend more money with my guys than I did for you. If I told a lie, I did it for you. And you my overplug. If another try, electrocute. Spend more time in my hustle than I did with you. Used to spend more money with my guys than I did for you. If I told a lie, I did it for you. And you my overplug. If another try, electrocute.
As we await the launch, let me tell the viewers about the flight events for LVM-3 M4 Chandrayaan-3 mission. At T0, the twin S-200s will be ignited and the mighty LVM-3 rocket lifts off. The core L110 stage is airlit 108 seconds into the flight, while the rocket is at an altitude of 45 kilometers. The S-200 strap-ons and L110 will thrust together for the next 20 seconds. Thereafter, the strap-ons will separate at 127 seconds past launch time, while the rocket is at 62 kilometers altitude. The relative velocity gained by the rocket in the meantime is 1.59 kilometers per second. At an altitude of 71 kilometers, closed-loop guidance is initiated for LVM-3. Separation of payload fairing takes place at 195 seconds past the launch at an altitude of 115 kilometers. The core 110 stage, having completed its burn time of about 200 seconds, is separated from the ongoing rocket. This event takes place at 306 seconds into the flight. At this point of time, the altitude will be 175 kilometers and the rocket would have acquired 4.2 kilometers per second relative velocity. Then the upper cryogenic stage, C25, ignites 2 seconds later and continues to burn for close to 650 seconds. During the operational regime of C25, the largest relative velocity addition takes place. It increases from 4.178 kilometers per second to 9.804 kilometers per second. And the most awaited moment of the Chandrayaan-3 separation is scheduled to take place at 969.7 seconds into the flight. The altitude will be 179.3 kilometers, which is a part of elliptical transfer orbit of 170 by 36,500 kilometers. From then on, the mooncraft Chandrayaan-3 would commence its journey to the moon.
इस मिशन का काउंटडाउन 25.5 घंटे पूर्व शुरू हो चुका है और इस दौरान रॉकेट तथा अंतरिक्ष यान को पावर ऑन कर सभी तंत्रों की स्वास्थ्य जांच की जा रही है। इस दौरान L110 चरण तथा क्रायोजेनिक चरण पर ईंधन का भराव सुनिश्चित किया जा चुका है। यह काम प्रमोचन मंच से सुदूर स्थल पर पूर्ण स्वचालित तकनीक से पूर्ण सुरक्षा के साथ संपूर्ण किया जाता है। आप अभी अपनी स्क्रीन पर यहाँ व्यूअर्स गैलरी का दृश्य देख रहे हैं। बहुत भारी संख्या में यहाँ लोग उपस्थित हुए हैं इस रोमांचक दृश्य को देखने के लिए। मौसम विभाग के अनुसार मौसम पूरी तरह सामान्य अनुकूल है इस प्रमोशन के लिए। अब आपके सामने प्रस्तुत है LVM-3 का इंटीग्रेशन वीडियो।
We bring to you a small clipping of the integration video for the LVM-3 rocket.
Minus 25 minutes.
On your TV screens, you are watching the visuals from second vehicle assembly building where the full LVM-3 M4 rocket has been assembled. These are the strap-on boosters getting assembled segment by segment.
Roger.
Each S200 has got 3 segments
Roger.
called nozzle end segment, middle segment and head end segment, to which the nozzle is assembled, and one after the other the segments are joined together. When the fully assembled solid rocket booster is handled carefully with a crane and being lowered on to the mobile launch pedestal as an integrated rocket, the igniter assembly then takes place, and this is the strap-on nose cones. On your TV screens, it is the core L110 stage being brought to the second vehicle assembly building for tilting and assembly between the S200 boosters.
जी हाँ, अभी आपने देखा दोनों S200 स्टप-ऑन बूस्टर्स के साथ L110 को भी संलग्न कर दिया गया है और यह है क्रायोजेनिक अपर स्टेज, CH-25 कहा जाता है इसे। बहुत ही जटिल इंजन है ये C-20 इंजन। बहुत ही सावधानी पूर्वक पूरी दक्षता के साथ यह कार्य संपन्न किया जाता है। यह है इक्विपमेंट बे जो कि दिमाग है इस रॉकेट का, और यह है हमारा प्रोपल्शन मॉड्यूल, चंद्रयान 3 का प्रोपल्शन मॉड्यूल है ये। चंद्रयान 2 के पश्चात इसमें काफी सुधार किए गए हैं।
TCTC SHAR 1 and 2 confirm normalcy of both telemetry
758
carriers.
वॉट के सोलर पैनल्स लगे हुए हैं, 440 न्यूटन के थ्रस्टर्स हैं। और यहाँ आप देख रहे हैं लैंडर और रोवर को। ये रोवर है जो चंद्रमा में विचरण करेगा। पूरी सावधानी के साथ इसे संयोजित कर दिया जाता है और यह लैंडर मॉड्यूल रोवर के साथ अब इस लैंडर मॉड्यूल को प्रोपल्शन मॉड्यूल के साथ संयोजित कर दिया जा रहा है।
Minus 22 minutes. Request all stations change over to channel 2 at T minus 21 minutes. No confirmation
सभी
is needed
परीक्षण
to control.
पूर्ण होने के पश्चात
MCC confirms data from chain 2.
इस समुच्चय को
RSD confirms data from chain 2.
पेलोड फेयरिंग के अंदर सुरक्षित कर दिया जा रहा है। पेलोड एडेप्टर, अंतरिक्ष यान और पेलोड फेयरिंग, इन सभी के समुच्चय को एनकैप्सुलेटेड असेंबली कहते हैं। अब इसे व्हीकल असेंबली बिल्डिंग लाया जा रहा है और क्रेन की मदद से इसे क्रायो स्टेज के ऊपर संयोजित किया जा रहा है। अब पूर्णतः तैयार LVM-3 M4 रॉकेट व्हीकल असेंबली बिल्डिंग से निकलकर लॉन्च पैड की ओर जा रहा है। इसे मोबाइल लॉन्च पेडेस्टल पर रखकर करीब
21 minutes.
1 किलोमीटर की दूरी तय की जाती है।
Change over to channel 2.
Roger.
RSO to ROD, range safety systems are ready.
ROD Roger.
CNC to TTC director.
अब इसे सावधानी पूर्वक लॉन्च पैड ले आया गया है और बाकी की स्वास्थ्य जांच यहां से पूरी की
All
जाएंगी।
stations to note, event number 430 and 431 is completed. Chandrayaan 3
पूर्ण संयोजित और तैयार LVM-3M4 रॉकेट, आगे की जांच तथा तरल नोदक का भराव यहां संपन्न किया जाता है।
The LVM-3M4 rocket standing majestically against a picturesque background in the second launch pad. LVM-3 rocket will fly for the 7th launch today. 43.5 meters tall and 642 tons heavy launch vehicle has been operationalized after an experimental and 2 developmental missions. Mission executives on your screen. That's the spacecraft director
Control to note, event number 430
and associate spacecraft director. LVM-3 is India's largest and heaviest launch vehicle, ferrying Indian and international customer satellites.
Vehicle Director to Mission Director. LVM-3M4 launch vehicle is ready for the Chandrayaan 3 mission.
Mission Director Roger.
Mission Director to
अब हम उड़ान से 19 मिनट 12 सेकंड की दूरी पर।
Health is normal and cleared for launch.
Mission Director Roger. ROD to Mission Director. Range is ready for LVM-3M4 Chandrayaan 3 launch.
Minus 19 minutes.
Mission Director Roger.
TTC Director to Mission Director. All track stations and network is ready to support LVM-3M4 Chandrayaan 3 mission.
रेंज ऑपरेशन डायरेक्टर, टेलीमेट्री ट्रैकिंग एंड कमांड डायरेक्टर, सैटेलाइट डायरेक्टर और व्हीकल डायरेक्टर अपने तंत्रों की जानकारी मिशन डायरेक्टर को देते हैं।
All necessary clearances are obtained for the launch of LVM-3M4 Chandrayaan 3 mission. Mission Readiness Review Committee and Launch Authorization Board have already given authorization for the launch of LVM-3M4 Chandrayaan 3 mission. Based on the readiness of vehicle systems, range, spacecraft and TTC confirmed by respective mission executives and the prevailing favorable weather conditions, Mission Director hereby authorizes for the launch operation sequence of launch of LVM-3M4 Chandrayaan 3 mission at 14 hours 35 minutes 17 seconds Indian Standard Time today, the 14th July 2023 from second launch pad of SDSC SHAR.
Control Roger. All stations to know, Mission Director has given authorization for launch.
जी हाँ, अभी आपने घोषणा सुनी। मिशन डायरेक्टर ने इस लॉन्च के लिए ऑटोमेटिक लॉन्च सीक्वेंस शुरू करने का अनुमोदन दे दिया है। इसके पश्चात व्हीकल डायरेक्टर ALS ऑटोमेटिक लॉन्च सीक्वेंस शुरू करेंगे।
On your screens, you have just watched Mission Director Shri Mohan Kumar giving clearance for the initiation of automatic launch sequence. This is based on the confirmation of readiness of all participating team for range, launch vehicle, spacecraft and tracking. The automatic launch sequence is scheduled to begin at T-14 minutes 30 seconds, as a part of which the most critical control system elements are checked for the launch vehicle.
Minus 17 minutes.
Very close to the launch time, control will be passed on to the onboard computers.
VLCC to LCC to note. Timing
व्यूअर्स
confirmed
गैलरी दर्शकों
external
से
full
खचाखच भरी हुई।
VLCC Roger.
बहुत भारी संख्या में यहाँ लोग उपस्थित हुए हैं। आप सभी का हार्दिक स्वागत है सतीश धवन अंतरिक्ष केंद्र में।
Enthusiastic viewers from all across the country gathering at Satish Dhawan Space Center Launch View Gallery for witnessing this historic moment of Chandrayaan 3 launch.
Stations. Copied.
The countdown for LVM-3 M4 Chandrayaan 3 mission has lasted for 25.5 hours. It was commenced on 1:30 p.m. yesterday.
While of operation of hydrogen tank.
During countdown, the launch vehicle stages are serviced with propellants.
Vehicle Director to
Gas
ALS
bottles
control.
meant for stage
Vehicle
operations are
Director
charged.
authorizes
While the Earth's
Automatic launch
storable
sequence
propellant
for the
filling was
LVM-3
concluded
M4
more than
Chandrayaan 3
16
mission.
hours ago,
ALSC
the
Roger.
cryogenic propellants
SDS servers activated. MC confirms data from SHAR 1 and
अभी
SHAR
अभी
2.
कंफर्म किया गया है, व्हीकल डायरेक्टर श्री बीजूसी थॉमस ने ऑटोमेटिक लॉन्च सीक्वेंस शुरू कर दिया है। अब यह लॉन्च व्हीकल LVM-3 M4 रॉकेट ऑटोमेटिक लॉन्च सीक्वेंस के अंतर्गत है। इसका मतलब ऑन बोर्ड कंप्यूटर पूरी तरह स्वचालित हो चुका है।
ALS in auto mode.
we are very close to the launch, and the day of launch wind biasing data is fed during the countdown to the onboard computers to enable most suitable steering of the launch vehicle through atmosphere. Up next, we will watch a curtain raiser video on this
Event
mission.
number 465, request CGSS to confirm supply of GN2 to cryogenic.
Moon. This familiar object in the night sky has inspired the imagination of astronomers and ordinary people alike. From time immemorial, humans have marveled at the beauty of the moon, used it to count time and navigate the high seas. In modern times, Moon, the only natural satellite of the Earth, has acquired added importance due to the belief that Moon is the key to our understanding of the evolution of the solar system in general and Earth in particular. Besides, Moon's precious resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the Moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the Moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the Moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the Moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the Moon in 2009 was praised as a path-breaking discovery. The follow-on mission, Chandrayaan-2, had an orbiter, a lander called Vikram, and a rover named Pragyan. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the Moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the Moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the Moon allows heat to flow through it. The third one will study the plasma environment near the Moon's surface. And the 4th instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The 2 instruments on the rover help us study the composition of the Moon's surface using X-rays and laser respectively. While the lander and rover will be in direct contact with each other. the propulsion module circling the moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
आपके सामने हैं इसरो के अध्यक्ष श्री एस सोमनाथ। अभी अभी आपने देखा एक संक्षिप्त वीडियो जिसमें एनिमेशन की मदद से इस पूरे मिशन की यात्रा को बताया गया है, इस मिशन के ऑब्जेक्टिव को समझाया गया।
Chandrayaan-3 has two predecessors with destination moon as their mission objective. Chandrayaan-1, launched by PSLV-C57 in October 2008, included lunar orbiter and impactor. During the mission life of around 10 months, Chandrayaan-1 had mapped the minerals on lunar surface, acquired 70,000 images to help create 3D atlas of moon, and what's more, found water on moon's polar regions. Chandrayaan-2, launched by LVM-3M1 on 22nd of July 2019, consisted of lunar orbiter, lander named Vikram, and rover named Pragyan. The orbiter is still providing insightful scientific information through its payloads like spectrometers, synthetic aperture radar, and cameras.
चंद्रयान-3 की चंद्रमा की सतह में उतरने के इस मिशन को कुल 10 चरणों में पूरा किया जाएगा। संक्षेप में यह इस प्रकार है। सर्वप्रथम चंद्रयान-3 को LVM-3 प्रमोचक रॉकेट द्वारा पृथ्वी की एलिप्टिकल टारगेट ऑर्बिट, जो कि 170 बाई 36,500 किलोमीटर की ऑर्बिट है, उसमें प्रमोचित किया जाएगा। वहां से चंद्रयान में मैन्यूवर कर पृथ्वी की गुरुत्वाकर्षण की सहायता से चंद्रयान की गति को वृद्धि की जाएगी। फिर चंद्रयान पृथ्वी की कक्षा से निकलकर चंद्रमा की कक्षा में जाएगा। चंद्रमा की कक्षा में जाते ही उसमें फिर से मैन्यूवर कर चंद्रमा की 100 किलोमीटर की वृत्ताकार कक्षा में स्थापित किया जाएगा। फिर सही समय आने पर लैंडर मॉड्यूल को प्रोपल्शन मॉड्यूल से पृथक कर दिया जाएगा। यह आप अपनी स्क्रीन पर देख पा रहे हैं, यह है प्रोपल्शन मॉड्यूल। प्रोपल्शन मॉड्यूल का मुख्य उद्देश्य है लैंडर तथा रोवर को पृथ्वी की कक्षा से चंद्रमा की कक्षा में, जो कि 100 किलोमीटर की वृत्ताकार कक्षा होगी, उसमें उचित अभिवृत्ति में लैंडर मॉड्यूल को अपने से पृथक कर चंद्रमा की सतह पर भेजना है। ऐसा करने के लिए इसमें MMH और मॉन का प्रयोग कर 440 न्यूटन के थ्रस्टर्स वाले इंजन्स लगे हुए हैं। इसमें आवश्यक संचार सुविधाएं भी उपलब्ध हैं।
Speaking about the major milestones in the journey of Chandrayaan-3 to the moon, the spacecraft consists of propulsion module, lander and rover. Lander is planned to touch down at south pole of moon. The major 10 phases of the mission are: the first phase, called the Earth-centric phase, comprises of pre-launch, launch, ascent and earthbound maneuver. While the second phase is the lunar transfer phase, as the name suggests, the Chandrayaan spacecraft moves closer to the moon. Next 8 phases are in the moon orbit, the third being the lunar orbit insertion, followed by the moon-bound maneuvers phase, which mark the fourth phase. And next it is now that the propulsion module separates from the lunar module when 100 by 100 circular orbit of the moon is achieved. The Chandrayaan-3 in its sixth phase carries out D-boost
External power
from
withdrawn.
100 kilometers to 100 by 30 kilometers orbit, followed by the pre-landing phase as seventh phase, and then the most awaited
Flight
landing
coefficient
phase
loading started.
takes place.
Flight coefficient loading complete.
आपके सामने है मिशन नियंत्रण कक्ष का दृश्य। सभी सेंटर डायरेक्टर्स अपने स्क्रीन पर देख रहे हैं कि ऑटोमेटिक लॉन्च सीक्वेंस किस तरह पूरा हो रहा है। दर्शक दीर्घा भी इस इंतज़ार पे। प्रमोशन से हम 5 मिनट की दूरी पर हैं।
-5 minutes.
Most of you might recall the Chandrayaan-2 mission
MC confirms radar
and the
data.
intense moments when all the enthusiastic Indians were waiting for the touchdown of the lander on the surface of moon. The launch view gallery with the overwhelming crowd of visitors.
पूरे दर्शक दीर्घा यहाँ बहुत उत्साहित। मौसम में थोड़ी परेशानी हो सकती है, लेकिन सब अपनी सुविधाओं के साथ में यहाँ उपस्थित हुए हैं।
We are close to 4 minutes from the scheduled launch time.
-4 minutes.
Gaining from the heritage of Chandrayaan-2, the Chandrayaan-3 is upgraded in several aspects for the enhanced robustness
Pyro
through
and wall
extensive
battery
ground tests and simulation.
Onboard computer in flight mode.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है। इस दौरान सभी संचार तंत्रों की स्वास्थ्य जांच, बैटरी आवेशन पूर्ण किया जा चुका है। कुछ अंतिम गतिविधियां जैसे ऑनबोर्ड कंप्यूटर पर रियल टाइम प्रोग्राम लोड करना, पायरो लाइन को आर्म मोड में लाना, गैस टैंक का अंतिम आवेशन, और यह सभी घटनाएं संतोषजनक तरीके से पूर्ण की जा रही हैं।
-3 minutes.
अब हम उड़ान से 3 मिनट की दूरी पर हैं। प्रमोशन तथा इस प्रमोशन की घटनाक्रम को पहले ही बताया जा चुका है। सर्वप्रथम दोनों S200 स्ट्रप-ऑन बूस्टर प्रज्वलित किए जाएंगे T0 पर।
Pre-flight pressurization of the hydrogen tank commenced.
S200 के प्रज्वलन के 108 सेकंड के पश्चात L110 जो कि
-2 minutes.
तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू कर दिया जाएगा। L110 के प्रज्वलन के पश्चात करीब 137 सेकंड पर S200 बूस्टर्स को यान से पृथक कर दिया जाएगा।
We are close to 1.5 minutes from the scheduled launch time.
सभी दर्शकों को ज्ञात है यह एक ऐतिहासिक मिशन होने वाला है। पूरे भारतवर्ष की आंखें इसमें हैं। इस यादगार पल के लिए यहाँ सब उपस्थित।
-1 minute.
अब हम उड़ान से 1 मिनट की दूरी पर
minus 50 seconds,
All sequencers armed.
Stage ready.
minus
TB ready.
45 seconds, minus 40 seconds,
L110 VHPP open. MOV
minus
79
33
open.
seconds, minus 30 seconds,
Real-time programs activated.
minus 25 seconds,
L110 VSPP open.
minus 20 seconds, minus 15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
Here we have a majestic liftoff of LVM-3 M4 rocket carrying India's prestigious Chandrayaan-3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण उत्थापन LVM-3 M4 रॉकेट का। यह भीमकाय रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है। इसे हम यहाँ महसूस कर सकते हैं और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है। LVM-3 के उत्थापन के साथ ही हमारे अंतरिक्ष यान चंद्रयान-3 की चंद्रमा की यात्रा प्रारंभ हो चुकी है।
As the rocket is soaring through the clear skies, every second moving closer to the accomplishment of the most important milestone in its mission to moon. Every Indian witnessing the launch live is content with the feeling of watching history in the making.
चंद्रमा की सतह पर अपना छाप छोड़ने के लिए चंद्रयान-3 अपने मिशन को पूरा करने निकल चुका है। वर्तमान में दोनों S200 स्टेप ऑन बूस्टर सामान निष्पादन करते हुए अपनी निर्दिष्ट कक्षा की ओर बढ़ रहे हैं।
The S200 motors thrusting simultaneously, generating a peak thrust of close to 6,000 kilonewtons in vacuum. They are made of HTPB-based solid propellant, 204.5 tons in each strap-on, close to 2 tons of propellant being burnt each second.
S200 स्ट्रैप-ऑन बूस्टर्स का कुल प्रज्वलन काल 126 सेकंड का है और अभी अभी घोषणा की गई L110 स्टेज का भी प्रज्वलन शुरू हो चुका है।
Apart from the strap-ons, the core stage has also commenced its operation. This stage, based on combination
200 stages are separated.
of hypergolic earth storable liquid propellants UH-25 and N2O4. Now the S200s have been separated.
घटनाक्रम के अनुसार यह यान इस यान से S200 स्ट्रैप-ऑन बूस्टर्स को सफलतापूर्वक पृथक कर दिया गया है। यह काम सेपरेशन मोटर्स की मदद से किया जाता है। इसके बाद L110 तरल नोदक पर आधारित और विकास इंजन के साथ यह चरण सामान्य निष्पादन करता हुआ अपनी उद्दिष्ट कक्षा की ओर बढ़ रहा है। अब यान क्लोज लूप गाइडेंस के अंतर्गत है।
L110 stage performance normal.
The trajectory of launch vehicle is closely following the prediction.
Payload fairing separated.
जी हाँ, पेलोड फेयरिंग को पृथक कर दिया गया है यान से, क्योंकि यान अब 114.8 किलोमीटर की ऊंचाई प्राप्त कर चुका है। इस चरण का कुल प्रज्वलन काल 200 सेकेंड होता है और इस दौरान यह करीब 1600 किलो न्यूटन का प्रणोद उत्पन्न करता है।
We are 220 seconds past the launch time. Current altitude is 135 kilometers. In the 200 seconds of its operation, the L110 stage carries the rocket up to 175.5 kilometers altitude and imparts a relative velocity of 4.18 kilometers per second, that is 250 kilometers every minute.
L110 stage performance normal.
LVM-3 M4 रॉकेट का द्वितीय चरण पूर्णतः सामान्य निष्पादन करते हुए इस चरण में कुल 113 टन के तरल नोदक भरे जाते हैं। N2O4 तथा UH-25 अर्थ स्टोरेबल प्रोपेलेंट को ईंधन के रूप में प्रयोग किया जाता है इस चरण में।
Stage ignition is authorized.
अगला चरण C25 का प्रज्वलन भावी है।
Plus 5 minutes.
L110 stage thrust cut off and separated to C25 ignition command. 25 ignition confirmed.
That's a piece of really good news that the third stage has started its operation. The C25 stage has been ignited.
जी हाँ, एक बहुत ही जटिल प्रक्रिया होती है क्रायो इंजन का इग्निशन और इसके प्रज्वलन के साथ ही तालियों की गड़गड़ाहट से गूंज उठा है मिशन नियंत्रण कक्ष। तृतीय चरण C25 वर्तमान में प्रणोद उत्पन्न कर रहा है। पूर्णतः सामान्य, सभी तंत्र पूर्णतः सामान्य हैं।
118 kilonewtons thrust in vacuum is what the stage develops with its 28.6 tons propellant combination of liquid hydrogen and liquid oxygen. Present altitude is
performance normal.
तृतीय और यह अंतिम चरण है इस यान का C25। यह क्रायो ईंधन पर आधारित चरण है जिसमें लिक्विड हाइड्रोजन, लिक्विड ऑक्सीजन का इस्तेमाल होता है। इसमें कुल 28 टन का क्रायो ईंधन पूरी सुरक्षा तथा सावधानी के साथ भरा जाता है। इस चरण में 186 किलोन्यूटन का प्रणोद उत्पन्न होता है और यह करीब 640 सेकंड तक प्रज्वलित रहेगा। इसमें दिशा नियंत्रण के लिए इंजन जिम्बल का इस्तेमाल किया जाता है। क्रायो ईंधन का विशिष्ट आवेग 446 सेकंड के करीब होता है।
currently the rocket is at an altitude of 210 kilometers.
Plus 7 minutes.
While there is no much variation in altitude, this stage will add to the relative velocity immensely.
Cryo stage performance
अब आपको
normal.
पेलोड के बारे में जानकारी देते हैं। लैंडर मॉड्यूल्स पे कई वैज्ञानिक प्रयोगों के लिए पेलोड्स लगाए गए हैं।
India's prestigious lunar landing spacecraft Chandrayaan-3 moving closer to its intended injection spot in the orbit. The propulsion module provides propulsion for earthbound maneuvers, translunar injection, and moonbound orbits. It also has a payload to study the spectral and polarimetric measurements of Earth and lunar orbit. The abbreviated name of the payload is SHAPE. Among the payloads of the lander module, the following are included. A landwehr probe called Rambha to measure the near-surface plasma density, that is the density of ions and electrons, and its changes with time. The second payload is Chandra's Surface Thermophysical Experiment, or CHAST, to measure thermal properties of lunar surface near polar regions. to measure the seismicity around the landing site and delineating the structure of the lunar crust and mantle, payload ILSA is there. The rover, after its descent, will further the scientific study objectives through its own payloads. For better understanding of chemical and mineralogical composition of lunar surface, LIBS or laser-induced breakdown spectroscope is included. Another payload is the alpha particle X-ray spectrometer.
जी हाँ, लैंडर मॉड्यूल में 3 पेलोड हैं, रोवर में 2 और प्रोपल्शन मॉड्यूल में 1 पेलोड भेजा गया है। चंद्रयान 3 के स्वदेशी लैंडर और रोवर में नितभारों का इस्तेमाल किया जा रहा है। यह अंतर्ग्रही मिशन के लिए भी आवश्यक तकनीकों का प्रदर्शन करेंगे। लैंडर के पास यह क्षमता है कि वह चंद्रमा की उबड़-खाबड़ सतह में भी बड़ी सावधानी से उतर सकेगा और रोवर को बाहर लाने के लिए और संचार सुविधाएं प्रदान करने के लिए सक्षम होगा। चंद्रयान 3 के लैंडर और रोवर में कुल 6 नितभार हैं। रेडियो एस्ट्रोनॉमी ऑफ मून बाउंड हाइपर सेंसिटिव आइनोस्फीयर एंड एटमॉस्फेयर, जिसे शॉर्ट में रंभा कहा जाता है, यह चंद्रमा की सतह के पास प्लाज्मा के घनत्व तथा समय के साथ बदलाव का मापन करेगा। इसके बाद चंद्र सरफेस थर्मोफिजिकल एक्सपेरिमेंट चंद्रमा के ध्रुवीय सतह के आसपास की थर्मल प्रॉपर्टीज का मापन करेगा। इंस्ट्रूमेंट फॉर ल्यूनर सिस्मिक एक्टिविटी लैंडिंग साइट के आसपास के क्षेत्र में भूकंप जैसी गतिविधियों का पता लगाएगा। रोवर में चंद्रमा की सतह के तत्वात्मक विश्लेषण के लिए लेजर इंड्यूस्ड ब्रेकडाउन स्पेक्ट्रोस्कोप और अल्फा पार्टिकल एक्सरे स्पेक्ट्रोस्कोप इसका इस्तेमाल किया जा रहा है। एक बहुत ही दिलचस्प वैज्ञानिक नितभार है शेप स्पेक्ट्रोपोलैरिमेट्री ऑफ हैबिटेबल प्लैनेट अर्थ, जो कि चंद्रमा से पृथ्वी से परावर्तित नियर इंफ्रारेड किरणों का विश्लेषण दूसरे जीवन सहायक ग्रहों को खोजने में मदद करेगा। वर्तमान में C-25 इंजन कार्यरत है और पूर्णतः सामान्य प्रदर्शन कर रहा है। अब हम प्रमोशन से 700 सेकंड की दूरी पर आ चुके हैं। सापेक्ष गति 6.5 किलोमीटर प्रति सेकंड, ऊंचाई 191 किलोमीटर।
As we have told you about the Chandrayaan 3's upgrades in the aspects of enhanced robustness through extensive ground tests and simulation, during the last phase of landing, the module will have a vertical velocity of less than 1 meter per second and a horizontal velocity of less than 0.5 meters per second from a height of 3 meters. The lander legs are designed to be robust enough to drive the impact. The cameras are tuned to take pictures ahead of the landing and enable intelligent decision making for choice of best location to land, avoiding craters and boulders on lunar surface. The successive pictures will also enable the craft to determine its horizontal and vertical velocity in real time. Laser Doppler velocity sensor is an upgrade in Chandrayaan 3 over its predecessor. It helps to determine instantaneous velocity of craft. Insights into the behavior of Chandrayaan 2 in the last few minutes of its descent has revealed to the scientists the necessity for upgrade in the guidance algorithm. Inputs from various sensors are used by the autonomous navigation guidance algorithm of Chandrayaan 3 to plan the flight path to the most suitable landing spot. The engines of Chandrayaan 3 are capable of more gradual throttling also.
वर्तमान में हम प्रमोशन से 817 सेकंड की दूरी पर आ चुके हैं। करीब 950 सेकंड पर तृतीय चरण क्रायोजेनिक इंजन को शट ऑफ कर दिया जाएगा। और उचित अभिवृद्धि प्राप्त कर चंद्रयान 3 को यान से पृथक कर दिया जाएगा। चंद्रयान 3 को LVM-3M4 द्वारा एलिप्टिकल पार्किंग ऑर्बिट में लॉन्च करने के पश्चात 170 किलोमीटर की पेरिजी पर क्रमशः 5 बार मैन्यूवरिंग कमांड दिया जाएगा। 5वीं बार में यह पृथ्वी से चंद्रमा की ओर प्रस्थान करेगा, जिसे हम ल्यूनर ट्रांसफर ऑर्बिट के नाम से जानते हैं। फिर 5 अगस्त 2023 को यह चंद्रमा की कक्षा में प्रवेश करेगा और फिर क्रमशः 5 मैन्यूवरिंग के पश्चात प्रोपल्शन मॉड्यूल चंद्रमा की 100 किलोमीटर की वृत्ताकार कक्षा में स्थापित हो जाएगा। यहाँ यह उचित समय और अमृति में लैंडर मॉड्यूल को पृथक करेगा और 23 अक्टूबर 2023 को चंद्रमा की सतह पर लैंडिंग की प्रक्रिया शुरू की जाएगी।
Plus 15 minutes.
We have come close to 900 seconds after the launch. Currently, the C-25 stage is thrusting. Current relative velocity is 9.29 kilometers per second.
जी हाँ, कुछ ही क्षणों में हम देखेंगे तृतीय चरण LVM-3M4 रॉकेट का चंद्रयान को उद्दिष्ट कक्षा की ओर ले जा रहा है और उद्दिष्ट कक्षा प्राप्त होते ही और उचित अभिवृद्धि प्राप्त होते ही चंद्रयान 3 को अंतक्षेपित कर दिया जाएगा।
Cryo stage thrust cutoff. Satellite injection condition is achieved.
अभी पुष्टि की गई चंद्रयान 3 को प्रमोशन की कक्षा प्राप्त कर ली गई है।
Chandrayaan 3 satellite separated.
चंद्रयान 3 को सफलतापूर्वक अंतक्षेपित कर दिया गया है एलिप्टिकल पार्किंग ऑर्बिट पर।
Chandrayaan 3 has attained a major milestone successfully.
Chandrayaan 3 mission accomplished. Handing over to mission director.
This is mission director. The LVM-3M4 Chandrayaan mission accomplished its precise satellite injection conditions. LVM-3M4 mission is successful. Jai Hind.
The launch has also added a feather in the cap of LVM-3 rocket. You can watch the jubilant congratulatory gestures of ISRO scientists in the Mission Control Center.
जी हाँ, चंद्रयान को सफलतापूर्वक अंतक्षेपित कर दिया गया है, लेकिन चंद्रयान 3 की यात्रा अभी जारी है। अब इस मिशन के बारे में हम अध्यक्ष महोदय से सुनेंगे और हम आपसे आज्ञा लेते हैं।
We sign off. Up next is address by Secretary DOS, Chairman ISRO.
Congratulations, India. Chandrayaan 3 has started its journey towards moon. Our dear LVM-3 has already put Chandrayaan 3 craft into the precise orbit around Earth. 170 by 36,500 kilometers was its intended target orbit, and it is precisely there now. And let us wish all the best for the Chandrayaan 3 craft to make its further orbit racing maneuvers and travel towards moon in the coming days. So let me wish all the very best to Chandrayaan 3 for its further journey towards moon. Before that, let me introduce the team behind this mission, the mission director, Mr. Mohan Kumar, and also the project director of LVM-3, and we have also the mission director for the Chandrayaan 3 craft, the project director of Chandrayaan 3, Veera Muthuvel. So over to them, Mohan.
Thank you, sir.
Honorable Minister of State for Science and Technology and Departments of Space and Atomic Energy, Dr. Jitendra Singh, respected Chairman ISRO and Secretary Department of Space, former secretaries of the department, invited dignitaries, respected dignitaries and invitees. I am very happy to report here that the LVM-3 M4 vehicle has injected the Chandrayaan-3 satellite to the precise orbit, and once again the vehicle is proved to be the most reliable heavy lift vehicle of Indian Space Research Organization. Congratulations to the teamwork of ISRO family. I would like to appraise three things here. The vehicle systems are in the continuous process of quality improvement, especially in the event of our human rating efforts towards making the systems reliable. Secondly, the payload also, capability of the payload also is improved by mission strategies as well as vehicle engineering approaches. We are in the process of increasing the launch frequency of this vehicle considering the national requirements as well as satellite demands. Here, so many improvements we have incorporated in this vehicle. For example, the S200 nozzle, they are processed exactly as per the human rating standards, enabling us to have 100% NDT, and the inherent pocket erosion characteristics are removed. The L100 stage Vikas engine, mostly it is 100% qualified to be the human rated engine with indigenously developed LET throats, and the pocket, the backward gas entry also is eliminated, and it is a perfect system. And CE20 stage also is perfectly, actually, sir.
Good. So we will describe all those details later because of shortage of time.
Yes, sir. I take this opportunity to thank all the mission executives because mission executives for all the supports all along the launch campaign process as well as the launch. Once the launch manifest is released and mission executives are identified, really this is a penance of so many across the ISRO centers, our launch vehicle centers, VSSC, LPSC, IPRC, IASU, SDSC, SHAR, URSC and SAC, along with all our industrial partners, major players to the small-scale industries who supply us with all the deliverables in time, quality products, the suppliers of chemicals, propellant ingredients, suppliers of avionics systems, and our own GOCO facility operators. Actually, the industrial manpower is really our ISRO's virtual manpower. Everybody's efforts went into this, and called the also the prayers and best wishes of all our seniors, retired executives, everyone's prayers and our own family members. I take this opportunity to pray God Almighty for all the blessings in the form of this success, which was the penance by the ISRO family for last 73 days. And my prayerful pranams for the successful continuous operations of the Chandrayaan spacecraft, for its safe and soft landing on lunar surface and further experiments. Thank you. Jai Hind.
Respected Chairman ISRO, Center Directors, dignitaries and my team Chandrayaan-3, very happy to note that our Chandrayaan-3 has been injected into an intended orbit with very close orbital parameters. Congratulations and thanks to LVM-3 team. And all our spacecraft health parameters are normal, including the power generations in both propulsion module and lander module. Our journey to moon has begun now for the most awaited soft landing. We'll be closely monitoring and controlling the spacecraft from ISTRAC Bangalore. Many critical events are lined up, starting from earthbound maneuvers, insertion into the lunar orbit, and separation of lander, and set of deboost maneuvers, and finally the power descent phase for a soft landing. I take this opportunity to thank Chairman ISRO, Director URSC, and all the center directors for entrusting me this opportunity, who have been the motivational and guidance force behind this mission. My special thanks to Chandrayaan-3 project executives, Associate Project Director Kalpana, Deputy Project Directors, Project Managers across the ISRO centers who have provided an excellent support in building the spacecraft. My special thanks to the expert committees for their constant guidance throughout the various stages of the project. I also thank the various work centers and industries who have contributed directly and indirectly to this mission. My special thanks to URSC council members, group directors, deputy directors across the ISRO centers, and looking forward for the soft landing with all your wishes and blessings from the God. Thank you.
We have our Honorable Minister for Space, Minister of State for Space, Dr. Jitendra Singh ji, amongst us during this historic occasion of success of launching of LVM-3. So we would like to hear a few words from him. Over to you, sir.
It is indeed a moment of glory for India and a moment of destiny for all of us over here at Sriharikota who are a part of the history in making. Thank you, Team ISRO, for making India proud. And thank you, Honorable PM Narendra Modi ji, for having made this possible by unlocking the gates of Sriharikota and enabling the India's space sector. You would recall, Honorable Prime Minister had very recently said, sky is not the limit. And living by his words, I think the Chandrayaan today has gone beyond the limits of sky to discover the unexplored horizons of the universe beyond. Ladies and gentlemen, this day today, the 14th of July 2023, is also a day of vindication. Vindication of the dream that Vikram Sarabhai saw 6 decades ago. He might have been short of resources, but never short of confidence. And when we see those pictures of a launcher vehicle being carried on the carriage of a bicycle, without any remorse, without any slightest embarrassment, that is because Vikram and his team had faith in themselves, faith in India's potential, faith in India's acumen. And today, here, we are vindicating and we are reiterating India's indigenous capabilities, living up to the ideal of Atmanirbhar Bharat. And before I conclude, ladies and gentlemen, as Mother India enters into the next 25 years of this Amrit Kal, she pledges to play a leading global role in the emerging world scenario of 21st century. Thank you and congratulations once again.
Thank you, sir. We will also introduce the directors of the centers who have done all those great work of building the rocket, building the scientific instruments for Chandrayaan-3, the Chandrayaan spacecraft itself, and made all those critical systems, and also the agencies who are going to handle the rest of the mission part, the tracking and the ground stations, and all those teams are here. So I request the directors of those centers to join. First, Director of Vikram Sarabhai Space Center.
Good afternoon, India. In last 1 year, this is the 10th mission, including the precise landing of the reusable launch vehicle. So with this mission, this is the 7th mission of LVM-3, the successful mission. With this, the success rate of LVM-3 is 100%. And this is the ideal vehicle for Gaganyaan. Some of the changes that we are incorporating in Gaganyaan, we have implemented here. And the Mark III has crossed the reliability of 0.9 and inching forward. So I take this opportunity to salute the entire ISRO community, especially the VSC community and all launch vehicle centers, industry partners for making the stages, making the sub-assemblies and testing. In fact, this is the third launch of LVM3 in 1 year. You know, the realizing the stages, assembling, testing, and then launching 3 LVM3s in 1 year is a Herculean task. I salute the industry as well as all the ISRO centers for this. And I wish all the very best. We know that when the beginning is good, the ending has to be good. I wish all the very best to the Chandrayaan for its solitary journey through the vastness of space and for making a feather-like soft landing in the 4th week of August. Good luck. Thank you.
Dr. Narayanan, Director LPSC.
Good afternoon to all of you. It is a historical event for Indian space program and a proud moment for all the Indians across the globe on this momentous occasion of the successful launch of the Chandrayaan-3. 3-in-1 spacecraft in the required orbit with the highest level of precision by our heaviest launch vehicle, LVM-3. After the 2 launches of LVM-3 vehicle this year, this vehicle is realized in the record shortest time. Today, once again, all the vehicle systems have performed, demonstrated the 7th successful launch. As you all know, the entire spacecraft community has put wholehearted effort during last 4 years, and we have realized a marvelous, great scientific satellite. For this mission, the entire vehicle performance is as expected, as predicted. In fact, the precision in which the satellite is launched shows the reliability of this vehicle. And we too have 4 liquid propulsion modules, 2 in the launch vehicle. The L1 stage, C25 stage, it has performed extremely well along with all other vehicle systems. We too have 2 more propulsion modules, one for taking the spacecraft to the moon, another one for soft landing. I think it is already well integrated, the system health is very good. Today's success is the culmination of the dedicated, smart and hard work of all the ISRO team members and the work culture of ISRO and the review process what we follow. I am sure all further mission operations will be a grand success and we'll have the successful soft landing. On this occasion, let me congratulate and compliment the members of ISRO team, our family members who have really sacrificed, the partners from industry and academia, and the various review fora. Thank you. Jai Hind.
The Chandrayaan craft was built at the UR Rao Satellite Center, so I request the Director of URSC to speak.
Good afternoon, ladies and gentlemen. I take this opportunity to first thank my colleagues from the Launch Vehicle Center for providing a textbook-like launch for Chandrayaan-3 on its journey towards moon. Thank you very much. And as Director LPSC and Director VSSC mentioned, realizing this kind of launch vehicle, third launch vehicle within a year's time is indeed a Herculean task. And thank you very much for the effort that has been put by all the members of the launch vehicle community and the industry supporting them. Coming to Chandrayaan-3, Mohan was telling that it is a penance. In fact, it is a penance of the Chandrayaan-3 team for the last 4 years, which has come today as an outcome. It is sitting like a brain sitting inside the head of a human being on that mighty vehicle. On top of that, that satellite was sitting, and it was such a happy moment to see that satellite getting separated. And our work continues from now for the next 42 days till we reach the lunar orbit and touch down softly on moon. So we'll speak the rest of the things after the soft landing on top of moon. Till then, thank you very much for all the members of the satellite community and the industry for your support, which has been continuing over several years, and I am sure will continue in future also. Thank you very much.
Space Applications Center Ahmedabad plays very important role in our scientific instruments and building of the satellites. Over to Director SAC, Nilesh Desai.
Thank you. Good afternoon, everybody. At the outset, let me compliment Team ISRO for this excellent work, and especially vehicle team as well as the project team. And as we begin this historic journey towards moon, well begun is half done, as it is said. So I'm sure that we'll succeed in our effort and endeavor to land on moon safe and in secure manner with a soft landing after 45 days. So I wish all the best to all the people who have contributed directly or indirectly, and especially to the project team, spacecraft team, as well as my team at Space Applications Center, who has developed sensors and other hazard detection and avoidance system which will help for a secure and safe landing on moon. So once again, I thank all who have contributed in this mission. Thank you.
Director of this center, Satish Dhawan Space Center, is the chairman of the Launch Authorization Board and also realizing the solid motors of this rocket. So over to Director SDSC SHAR Rajarajan.
Honorable Minister of Science and Technology, Dr. Jitendra Singh, respected Chairman, our mentors and the dignitaries present here, and the entire ISRO family, a very successful launch and hearty congratulations to all the LVM-3, M4 and Chandrayaan-3 mission. So once again, the Fat Boy has done its job and put a very precisely our prestigious lunar mission Chandrayaan-3 in the transfer orbit. And I congratulate the SDSC SHAR team, because throughout this launch, we had many launch campaigns of C57 and 56. Along with that, we are proud to have this. In spite of the weather conditions here, we have successfully launched LVM-3 in the prescribed launch window time between July 12th and 19th. And we had a very good, smooth campaign here, and all the hearty congratulations to the entire launch vehicle team, as well as for the last 2 months for hosting the Chandrayaan-3 team here and carrying out all the tests to make sure that Chandrayaan-3 is also ready for the mission. And I also thank our entire logistics team who handled this huge crowd throughout this campaign period, in particular last 2-3 days. And my sincere thanks to the various Indian industries who are now participating in various aspects of solid motor processing as well as the assembly activities of our launch vehicle to make it successful. And I wish a glorious success in the future to come. And I wish, as mentioned in the last week of August, to have a successful soft landing of Chandrayaan-3 lander on the moon surface and to make history. Once again, thank you. Jai Hind.
I request all center directors to join on the podium. Please come, all of you. Can you lower this? Please come. Please come here. Come. Please come.
नमस्कार, स्वागत है आप सभी दर्शकों का इसरो के एक और महत्वपूर्ण मिशन जिसका नाम है PSLV-C54 EOS 06 मिशन। मैं विकास स्वर्णकार सतीश धवन अंतरिक्ष केंद्र से आप सभी दर्शकों का हार्दिक स्वागत करता हूं। मेरे साथ सह कमेंटेटर के रूप में है मिस पी माधुरी। आज 26 नवंबर 2022 को भारतीय मानक समय के अनुसार सुबह 11:56 पर PSLV-C54 का प्रमोशन श्रीहरिकोटा के प्रथम प्रमोशन मंच से किया जाएगा। इसी अनुसार सारी गतिविधियां सुचारू रूप से जारी हैं। कुछ अंतिम गतिविधियों तथा जांचों के पश्चात PSLV-C54 का प्रज्वलन 11:56 पर किया जाएगा। इस प्रमोशन की उल्टी गिनती 25.5 घंटे पहले प्रारंभ हो चुकी है और इस दौरान सभी अंतिम कार्यों को संतोषजनक तरीके से पूर्ण किया जा रहा है और अब हम उड़ान से 24 मिनट की दूरी पर हैं।
Namaskar and good morning viewers. You are watching the live telecast of launch of PSLV-C54 EOS 06 mission. I am Madhuri bringing to you the commentary from the Mission Control Center broadcasted by DD National. The live coverage is also available on ISRO website, YouTube, Facebook and Twitter. With me is my co-commentator Shri Vikas Swarnkar. Now, before moving on much with the views of the launch, we bring to you a curtain raiser video regarding this mission.
Welcome to Elucent, where our dedicated clinical pharmacology, modeling, and simulation experts are spotlight focused on small to mid-sized biopharma companies. Our A-team of scientists and consultants translates complex data into actionable insights that enable our partners to make better strategic decisions and optimize their clinical and non-clinical studies. From candidate selection, first in human, proof of concept to registration, and beyond, we provide specialized expertise to help avoid costly missteps and services that deliver throughout the clinical development spectrum to understand the value of the treatment for patients. We leverage data from studies and many other sources to build custom models and plans with the aim to improve clinical trial design, define dosing, predict outcomes, and inform development decisions with quantitative evidence, leading to more efficient, less costly, and more precise research. At Elucent, we bring our passion for innovation, unparalleled expertise, and partnership approach to every collaboration, so that our partners succeed in delivering novel treatments to patients worldwide. Elucent is a global provider delivering comprehensive drug development solutions that is small enough to care deeply about our partners' success and big enough to deliver on their diverse set of needs.
ISRO's workhorse PSLV in its flight C54 is ready to launch EOS-06 satellite along with 8 nanosatellites into 2 different SSPOs. The mission is targeted to launch from Satish Dhawan Space Center SHAR on 26 November 2022. EOS-06 is third generation satellite in the OceanSat series, which provides continued services of OceanSat 2 with enhanced payload capability.
EOS-06 OceanSat-3 spacecraft is a third generation satellite to study the biological parameters of ocean. This is having advanced payload specification as well as application areas. The satellite is realized on I-1K bus having lift-off mass of 1115 kg. It will put into the orbit height of 732.5 kilometers. It is an operational class spacecraft with complete redundancy, providing 5 years mission life.
The satellite on board carries 4 important payloads, namely Ocean Color Monitor OCM3, Sea Surface Temperature Monitor SSTM, KU Band Scatterometer SCAT3, Argos. The OceanSat 2, which was launched during September 2009, configured to cover global oceans and provide continuity of ocean color data with global wind vector and characterization of lower atmosphere and ionosphere. The mission resulted in many research collaborations nationally and internationally on various areas: global chlorophyll distribution, KD490 distribution, ocean color images, oil spillages, wind vector products. The EOS-06 is envisaged to observe ocean color data, sea surface temperature and wind vector data to use in oceanography, climatic and meteorological applications. The satellite also supports value-added products such as potential fishing zone using chlorophyll, SST and wind speed and land-based geophysical parameters. The primary satellite EOS-06 will be separated in Orbit 1. Subsequently, orbit change is planned by using two orbit change thrusters (OCTs) introduced in the propulsion bay ring of the PSLV-C54 vehicle. The passenger payloads PPLs will be separated in Orbit 2. India-Bhutan SAT, a collaborative mission between India and Bhutan, is INS-2B satellite for Bhutan with two payloads, namely Nano-MX, a multispectral optical imaging payload developed by Space Applications Center, and APRS Digipeater, which is jointly developed by DITT Bhutan and URSC. The other three payloads are commercial payloads from NSIL. The Anand 3 axis stabilized nanosatellite from Pixel India. Astrocast is a 3U spacecraft with 4 numbers of satellites. An ISI Space Quad Pack dispenser is from Spaceflight Inc., USA. The Thai Bolt is a 0.5U spacecraft bus that includes a communication payload from Dhruva Space using their own orbital deployer with a minimum lifetime of 1 year.
बैठी बैठी में तूने आग भर दी, खाली बोतल में शराब भर दी। तेरी कसम बिल्कुल सीधी सादी थी, मैं तूने लड़की खराब कर दी।
तो समझ ले, मैं बोलूं का मैं आंखों से पढ़ ले। गेम के टॉप पे बैठा, जिसके भी बस की वो आके पकड़ ले। इनसे गेम क्रैक ही नहीं हो रहा ना, हिट कोई ट्रैक ही नहीं हो रहा ना। यहाँ फिर मैंने सीन चेंज किया और कुछ लोगों का कमबैक ही नहीं हो रहा। बादशाह है नाम मेरी जान, प्यार से मुझको वो पैडी बोलती है। गेम में लॉन्डो का बापू बेबी, एक तू ही थोड़ी है जो मुझे डैडी बोलती है।
सुबह से शाम तक बस तेरा नाम लूं, तुझको जो देखूं मैं दिल अपना थाम लूं। जो तू मुझे छू ले तो बदन में सनसनी, खुद को समझाती हूँ कि सब्र से काम लूं। नींदें मेरी तू खराब कर दी।
कोई उंगली करता है हाँ, तो मैं बाँ भी चढ़ाता हूँ, पर सामने हो बंदी तो मैं गुड बॉय बन जाता हूँ। या उड़ती हैं खबरें लेता न स्ट्रेस, गेम का कार्ट ऑन टू द नेक्स्ट। ब्रेन है प्राइवेट, लाइफ है ब्लेस, मुट्ठी में गेम मेरे घंटे पे प्रेस। बैड बॉय शाह कैसे तुझे तेरे बस का लगा, न मुझे ऐसे मस्का लगा। रही ना किसी काम धाम की जब से लड़की को चस्का लगा मेरा। या boy, बादशाह,
लड़की खराब कर दी।
You have just heard from the project director of the primary satellite EOS-06 and the details about the passenger payloads. The launch is scheduled to take place today, the 26th of November 2022 at 11:56 hours Indian Standard Time from the first launch pad at Satish Dhawan Space Center, SHAR, Sriharikota, which is located on the eastern
Minus
coast of
19
India.
minutes.
This mission is configured with PSLV-XL carrying EOS-06 weighing 1150 kg and injecting in 742.93 kilometers altitude with 98.34 degrees inclination and 8 other passenger payloads at 511.2 kilometer circular orbit with 97.45 degrees inclination. Launch of PSLV-C54 marks the 5th launch of ISRO in the year 2022. Apart from the workhorse PSLV's 2 flights, the new rocket SSLV undertook its maiden flight, and LVM-3 successfully deployed 36 satellites in its first commercial mission.
CNC to TTC Director, all strike elements are ready to support PSLV-C54 EOS-06 INS-2B mission.
अब हम उड़ान से 18 मिनट की दूरी पर हैं। तब तक आपको मिशन विवरण दे देते हैं। PSLV-C54 EOS-6 मिशन, इस मिशन में मुख्य उपग्रह के रूप में EOS-06 नामक 1115 केजी का भूप्रेक्षण उपग्रह है, जिसे लगभग 742 किलोमीटर की वृत्ताकार कक्षा में 98.34 डिग्री के झुकाव के साथ स्थापित किया जाना है। मुख्य उपग्रह के साथ अन्य 8 सहयात्री उपग्रह के रूप में अपनी कक्षा की ओर इस PSLV-C54 में सफर कर रहे हैं। इस मिशन में सर्वप्रथम EOS-06 उपग्रह को 742 किलोमीटर की कक्षा में स्थापित करने के पश्चात अन्य 8 उपग्रहों को निचली कक्षा में स्थापित किया जाएगा और यह ऑर्बिट कक्षांतर ऑर्बिट चेंज थ्रस्टर्स की मदद से किया जाएगा। यह मिशन लगभग 7521 सेकेंड का होगा।
VLCC noted.
Spacecraft directed to mission director. EOS-06 spacecraft is ready for launch.
Mission Director Roger.
प्रमोशन की उल्टी गिनती 25.5 घंटे पहले शुरू हो चुकी है और इस दौरान गतिविधियां जैसे यान को पावर ऑन करना, सभी तंत्रों तथा नियंत्रण प्रणाली की स्वास्थ्य जांच करना, तरल नोदक के भराव की स्थिति प्राप्त कर भराव शुरू करना, उपग्रह को पावर ऑन करना, बैटरी आवेशन करना आदि सभी गतिविधियों को संतोषजनक तरीके से पूर्ण किया जा चुका है।
TCTC data loggers are on at SHAR and SHAR2.
सभी घटनाएं पूर्ण निर्धारित होती हैं, इसलिए सभी टीम अपना काम सुनियोजित तरीके से पूर्ण करती हैं।
-16 minutes.
The countdown for PSLV-C54 EOS-06 mission lasted for 25.5 hours and
for proceeding with the countdown and launch of PSLV-C54 EOS-06 mission. All operations in the countdown sequence till automatic launch sequence have been completed satisfactorily. Based on the clearance obtained from launch vehicle, spacecraft, range and ISTRAC network stations and prevailing favorable weather conditions, Mission Director hereby authorizes to initiate launch operation sequence for the launch of PSLV-C54 EOS-06 mission at 11:56 hours IST today, that is 26th of November 2022.
Control Roger. All stations to note, Mission Director has given authorization for launch.
This is Vehicle Director. Based on authorization from Mission Director, Vehicle Director hereby authorizes to initiate the automatic launch sequence for the launch of PSLV-C54 EOS-06 mission.
Automatic launch sequence initiated for PSLV-C54.
The automatic launch sequence has been initiated. The final capsule of checks for determining the health of rocket are carried out from the ground computers. Onboard computers take over very close to T0.